In this video, we're going to work example problems that are related to the general definition of trig functions, the most general definition. So not the unit circle definition, not the SOHCAHTOA definition that is used just strictly when you have an actual right triangle you're dealing with, but the definition that's like the unit circle definition, which we haven't talked about yet. However, the radius isn't constrained to be 1. The radius is whatever radius you pick. So let's get started. The Pythagorean theorem for right triangles states that the sum of the squares of the lengths of the legs is equal to the square of the Pythagorean theorem for any right triangle. The side opposite the right angle is the hypotenuse, and the legs are just any value A and B. The sum of the squares of the legs is equal to the square of the hypotenuse. In the definitions of the sine, cosine, secant, and cosecant functions, r is interpreted geometrically as the distance from a given point, xy, on the terminal side of an angle theta in standard position to the, so they're talking about the general definition, the most general definition of trig functions. You pick any point on the terminal side of where theta is that's in line with the kind of the line that theta fixes, and r is the distance from the point that you picked to the origin. For any non-quadrantal angle theta, sine theta and cosecant theta will have the what sign, same or opposite? We know that sine and cosecant are related in that sine theta is 1 over cosecant theta. So sine and cosecant are just reciprocals of one another. That means they're going to have the same sign. If cotangent theta is undefined, then tangent theta is equal to what? So undefined, how does a trig function become undefined? Well, it's because you're dividing by 0, which when you're thinking about the angle of any right triangle that's formed in the general definition, the angle with the origin being the vertex, the adjacent over the opposite is always the x value over the y value. So it's when the y value becomes 0, so you have an angle along the horizontal axis, so 0 or 180 degrees, is when cotangent is undefined. But the x value is a finite value. So tangent, which you flip the cotangent, means you're going to have, instead of the horizontal length, which in that case has magnitude equal to the radius, over 0, you're going to have 0 over the x value or the radius. So tangent theta is going to be equal to 0. If the terminal side of an angle theta lies in quadrant 3, then the values of tangent theta and cotangent theta are, so quadrant 3. Pick any point. Tangent and cotangent. Tangent is going to be the opposite over the adjacent. Both are negative. The y and the x are negative. So you end up getting a positive value. Cotangent is just the reciprocal, so it's the same sign as tangent. So this is going to be positive. And all other trigonometric function values are going to be negative. Why negative? Because all other trigonometric values are, it's one of the sides divided by or in ratio with the radius. The radius is always positive. But both of these are negative. So you're always going to have, for all the other trigonometric functions, you're always going to have a negative value. If a quadrantal angle theta is coterminal with 0 degrees or 180 degrees, then the trigonometric functions what and what are undefined. Well, we just talked about this. If you're coterminal with 0 or 180, that means it's an angle that lies along the horizontal axis. In that case, when you think about the right triangle, the y value is 0. And so for which trigonometric functions are we dividing by the y value? Well, okay, tangent, you're doing opposite over adjacent, which is you're dividing by the x value. So cotangent, you're dividing by the y value. What else? Well, if we think about the sine, that's opposite over adjacent. And so for any, again, in any quadrant, you're going to have, since we're always thinking about the angle has the angle that has vertex of the origin, and then we're always making a right triangle has the perpendicular with the horizontal axis, the opposite over the hypotenuse, that opposite is always going to be the y value. Well, the y value is 0, so sine is, you're going to be 0 divided by a number, that's 0. So undefined would be the reciprocal of sine, which is cosecant. Okay, the terminal side of an angle theta in standard position passes through the point -3, 3. Use the figure to find the following values. Rationalize denominators when applicable. All right, so we're thinking about the general, we're working with the absolute general definition of trig functions. So that's why we're not working with the unit circle yet. We have just this radius r. How do we interpret the absolute general definition of trig functions? Okay, well, the idea is we've got an angle theta. It's in the third quadrant. And so you picked a point in the third quadrant that's along the line that theta restrains, right? You can't pick, if you pick the point here, well, you're off what theta restrains you to. So you pick any point along this line, and they picked -3, 3. All right, so again, just to explain this one more time, we're interested in finding trig functions, evaluating trig functions for some angle theta. That's the whole goal here. And we're going to use the most general definition of trig functions to do this. Okay, so this angle theta is in the third quadrant, and the angle theta creates a line that goes off to infinity, but it doesn't extend. It stops at the origin. You can't go into the first quadrant because the angle is in the third quadrant. But you're restricted. You're going to pick any point you want on this line. Any point you want. It has to be on the line though, because if you come here, then now you've gone away from theta. You have to follow what the angle you're interested in evaluating the trig function of. That you're constrained by that. So the first step is you pick any point you want along this line. They've picked -3, 3. -3, -3. Okay, so when you do that, then that gives you the coordinates. So you have this x and this y, and both are minus though, right? We're following this coordinate system here, which is based on what we talked about, an angle in standard position. An angle defined from standard position is just like this. So based on the coordinate system, this is -3 in the x, -3 in the y. So they want to know, okay, what is r? Well, we find r using the Pythagorean theorem. So r squared is x squared plus y squared. So r is equal to the square root, the principal root of x squared plus y squared. So r is equal to -3 squared is 9. -3 squared is 9. Okay, now this is 9 times 2. So r is equal to 3 root 2. And you can see r is always positive because you've got this principal root, and then inside the root is just always a positive number. Okay, what is sine theta? Well, what you do is, and you have to be really careful here, but we're going to come, you always, every time you do this with this general definition, you create a right triangle, because you have your point, and you always create a right triangle for any quadrant. You create a right triangle that has the perpendicular angle with the horizontal. So once you have that right triangle, you come to the angle that has vertex at the origin. You look at this angle, but I'm not labeling it. I don't even want to label it, because it's easy to forget that we're not evaluating trig functions of this angle. We're evaluating trig functions of this angle. But we're still going to come, for any situation, we're going to come to this angle inside the right triangle, and then we're going to do the SOHCAHTOA method. Right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. However, we just have to keep in mind that we're honoring these. if these values are negative or positive. Like the opposite over here, the opposite and the adjacent could be potentially be negative or positive. But the R is always going to be positive. Right? So like in general, if we're doing the SOHCAHTOA method on just a random right triangle, just a general right triangle, well, there's no such thing as negative side lengths for a triangle. This is just for this definition of trig functions. That setup here is all this is about. In an actual real situation, you don't have negative side lengths of triangles. Okay, so what is sine theta? Okay, sine of this theta, we've got our right triangle drawn and everything's all labeled out. We know what R is, so we need to know R because now we come to this angle here that's with the vertex is the origin, and then we do SOHCAHTOA. So sine is what? Opposite over hypotenuse. Minus 3 over the hypotenuse, which is 3 root 2. So minus 3 over 3 root 2. Well, let's come out here. So, because we're going to need to rationalize this. Okay, so this is minus 1 over root 2. This is sine theta. Okay, but they want us to rationalize, so we can't have roots in the denominator, so we just multiply by 1 in the form of root 2 over root 2, and we were left with minus root 2 over 2. Okay, what is cosine theta? Same thing, come to this angle, and we SOHCAHTOA, cosine is adjacent over hypotenuse. That's minus 3 over 2 root, or no, minus 3, oh, it's the same thing. Minus 3 over 3 root 2. Now, is it the same sign? Yeah, exact same. Minus root 2 over 2. Okay, tangent theta, SOHCAHTOA. Tangent is opposite over adjacent. Opposite over adjacent. Minus 3 over minus 3 is positive 1. And there we go. Okay. Sketch an angle theta in standard position such that theta has the least positive measure and the given point is on the terminal side of theta. Then find the values of the 6 trigonometric functions for each angle. Rationalize denominators when applicable. Okay, so this is more practice on the general definition of trig functions. So what we're going to do is we have 10 tick marks, so let's do minus 20 to 20. Okay, so what they're just saying that we have a point here, and it's on the terminal side of theta, and so all this is telling us, this is giving us what the theta is, or at least a picture of it. We don't have the skills to actually, we haven't learned enough to actually figure out what the angle is, but it'll, okay, so let's plot 5 minus 12. So each tick mark is 2, 4, here's 5, and then minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. Okay, it's giving us the theta in this sense. That's the theta. Okay, this is just all about the general definition of trig functions. Again, I just want to stress that we're just learning the mechanics of the general trig function definition. Okay, now they say least positive measure. Well, what they mean by that is, so okay, we could do this, but that would be a negative angle, so that's not positive. But we could, so this angle we could draw it like, that, like, you're adding 360 to that theta. That has the same, representation as far as the terminal position that the 0.5 minus 12 creates, but that's not the least positive. So that's what they mean by least positive. All right, so there's the sketch of the angle theta that has the least positive measure based on the terminal position of 5 that the 0.5 minus 12 indicates. Now we want to find the values of the 6 trigonometric functions for this angle. But we don't even need, notice that we don't even need to know what the angle is. Later in trigonometry, we'll be able to figure out what this angle is with just this information here, no problem. But technically, right now, we can't do that. But it doesn't matter. We can still find trig functions of this angle. And if that seems weird to you, just remember with this line here, this is a specific angle now. Like, this isn't variable. We can't move this angle. This is an actual angle. We can't figure out what it is. But this is a one angle. We've restricted it with this line. So an angle, any angle, a specific angle is going to have, trig function values, right? So that's what we're finding. We can find those without actually figuring out what the angle is. Okay, so how do we do this with the general definition? Well, we pick a point along this line, but that point we're gonna use 5 minus 12. So here's the point, and then from here we create a right triangle by with the side, the perpendicular angle is on the horizontal axis. We do that. And then the side lengths, we know the side lengths because we know the coordinates of the point. So it's 5 minus 12. But the key is, we want to, if it's a negative side length, we want to put that negative based on the coordinate system, right? There's triangle side lengths are never negative. You don't think in real life, you don't think about triangles having a negative side length. But just for this, this system here for defining trig functions, we make sure that we indicate if one of the side lengths is negative. So we put negative 12 here because this is in the negative y, this is the positive x. Okay, then we want to find out what the hypotenuse is. This is the radius. What is this radius? We use the Pythagorean theorem. We've got the 2 side lengths. So it's the r squared, that's the hypotenuse length. We call that the radius in the general definition, is equal to the square root of, or just x squared plus y squared. So r is equal to the square root of x squared plus y squared. So, okay, x squared is 25, y squared is 144, 5 squared is 25, 12 squared is 144. So we've got 25 plus 144. Square root of 169 should be 13. Okay. So this is 13. And r is always going to be positive. So now the next step is you come inside the triangle to the angle. You have 2 acute angles in any right triangle. You come to the acute angle that the vertex is the origin. And you do SOHCAHTOA with that. But you just make sure you honor the signs of these side lengths. Right? This is going to be a negative sign here, so we have to use that sign. But we're talking about this angle here. We don't care what this angle is. We don't. This is just the method. So, okay. Sine of theta, we do SOHCAHTOA with this angle, is opposite over hypotenuse. It's sine of theta, though. Theta. Right? We're not talking about the sine of this angle. This is just a technique for the general definition. We're talking about the sine of theta. We come to this angle and we say, okay, opposite over hypotenuse. But this is a negative 12. So negative 12 over 13. Okay, now we can go ahead and do the reciprocal of sine, which is going to be cosecant, which is confusing, right? Because you think cosecant, cosine, but it's the opposite. Cosecant is the reciprocal of sine. That's going to be minus 13 over 12. Okay, cosine theta is, come to this angle, the adjacent over the hypotenuse. That's 5 over 13. Okay, so the reciprocal of cosine is secant. Just flip this. Okay, tangent theta is opposite over adjacent, minus 12 over 5. Cotangent is the reciprocal of tangent. That's going to be minus 5 over 12, and there we go. Okay, same type of problem. Let's plot the point. minus 8, 15. So minus 2, minus 4, minus 6, minus 8. And then 2, 4, 6, 8, 10, 12, 14, 15. Okay, now we draw a line from the origin to that point. And so that with this point, the angle that we're wanting to evaluate trig functions of is defined. It's this angle. We want to get the trig functions, sine, cosine, tangent, etc. of this angle. All right, so what we do is, the next step is we create a right triangle that's the perpendicular is on the horizontal axis. So we come down here. Okay, then next we label the side lengths, but they could potentially be negative. This is going to be negative 8. This is going to be positive 15. Then we want to get the hypotenuse, but we call that the radius, right? And you know, we picked the point minus 8, 15, but just remember, we've talked about this in the previous videos, the lecture videos. We could do this with any point along this line, and we would get the same trig values, right? We're just talking about this angle. We could use any point along this line and do this exact same process, and the trig function values don't change because theta doesn't change. Okay, what is the radius? This is the radius. What is the hypotenuse? That's the hypotenuse length of that right triangle. So it's the square root of x squared plus y squared. That's 8 squared is 64. 15 squared is 225. So r is equal to plus 64, 17. So this is 17. All right. So what is sine theta? Come to this, the angle in the right triangle. That is the vertex, the acute angle that the vertex is the origin, and do SOHCAHTOA. So opposite over hypotenuse, that's 15 over 17. The reciprocal of sine is cosecant, so just flip this. All right, cosine theta, adjacent over hypotenuse, it's a negative 8 though. All right, reciprocal of cosine is secant, so minus 15 over 8. Tangent, opposite over adjacent. So it's minus 15 over 8. Cotangent, just flip it. There we go. Okay, wait, I messed some stuff up here. 15 over 17, 17 over 15. Cosine is adjacent over hypotenuse. This is not, this is 17. And so this is minus 17. Okay, 0, 2. So let's do minus 5. All right, so 0, and then we've got each tick is 0.5, so now this is a quadrantal angle. It's on, the angle is on one of the axes. And so this is a little bit different. It's not the same, you know, it's the whole right triangle and all that. This has its own, we look at this differently. Well, it's the same concept in the sense that we think about it, there's no right triangle to draw, but we think about it like, so if we, you know, we had, if theta was here, but then we're approaching the vertical, what's happening is the x value is going to 0, and the y value is going to be equal to the radius value. That's what happens. And not only that, but the y value is positive as well, because maybe the y value could, you could, when you can imagine when we come to theta is equal to 270 down here, yeah, the y value is equal to the radius value in magnitude, but the y value is negative. But here the y value is positive, and it's equal to r, just like the radius, and x is equal to 0. Okay, so in that case, we've got, so sine is, so it'd be helpful if we draw, let's just draw a triangle so we can see this. Right, so what we're thinking about is, like, if we come to this angle, we can imagine that where here's, we would, for the general technique, we come to the angle that is in the right triangle that is, has vertex of the origin, right? But we're dealing with this collapsed triangle, so we have to remember that. But we would do what? We would do sine theta is opposite over hypotenuse. Well, in that case, the opposite is the y, that's positive 2. And then the hypotenuse is the r, that's also positive 2. You see? Because think about it, if we have this triangle here, and that there's theta, but we keep increasing theta until we get to the vertical, well, the right, but imagine we still using the right triangle, well, the right triangle collapses, it's not a triangle anymore. But we're still using the same definition set up, and so we've got this collapsed quote-unquote triangle, but the y has become equal to the hypotenuse, but the y is positive, right? We could have a negative y. We could have, if we were at 270, and it was, this point was 0 minus 2, we'd have sine theta is equal to negative 2 over 2. But here, the y and the radius are the same, okay? And then you can see whenever we do cosine, it's the adjacent over the hypotenuse. Well, the adjacent, the x went to 0. The y goes to the radius, and the x goes to 0. So, okay. So sine of theta is equal to 1. And then cosecant theta, the reciprocal of sine, is also 1. All right, cosine theta is 0 over 2, right? X is 0, and the radius is the adjacent over the hypotenuse. The hypotenuse is 2. That's just 0. But then the reciprocal, which is secant, is not 0 because it's going to be, the cosine was 0, the adjacent over the hypotenuse, which is 2. So the reciprocal is 2 over 0. You can't divide by 0, so it's undefined. Okay. Tangent is opposite over adjacent. The adjacent is 0. That's 2 over 0, so that's undefined. The cotangent is going to be 0 because you've got the, in this case, it's the adjacent over opposite. That's 0 over 2. Okay, 0 minus 4. So let's do, we can do this again. All right, 1, 2, 3, 4. So we've got this angle. Okay, and so you think about this. If we imagine, we have a triangle here, and so the angle is here, and then we drop or we raise up, you could say, we create this right triangle. Okay, and so we're thinking about what happens when, so here's this angle, if we keep increasing that until it gets to the vertical. What happens? Well, the y value is equal to the radius, but the y is negative, and the x becomes 0. Okay, the radius is 4, right? There is no triangle, like this is just a visualization technique. There is no triangle. This is the triangle, it's a line. Okay, the radius is 4. Right, so the sine is, it's opposite over hypotenuse. Well, opposite is minus 4. And hypotenuse is 4, so sine theta is minus 1. Okay, so cosecant is also minus 1. It's just a reciprocal. All right, cosine theta is, so that's adjacent over hypotenuse. That's 0 over 4, which is 0. And then the reciprocal of that's going to be 4 over 0. So secant theta is undefined. All right. Tangent, opposite over adjacent. Adjacent is 0. That would be minus 4 over 0, which is undefined. But then the reciprocal of that is 0 over minus 4, which is 0. Okay, square root of 2 is about 1.41, so 0.51, 1.5, so about here, 0.51, right there. Okay, so now we create a right triangle with the right angle being in line with the horizontal. Here is we're looking at this angle theta, and it's the case, in this case, actually the angle in the right triangle has vertex at the origin is actually the same as the angle we're evaluating. That's the case for acute angles. Okay, now we've got root 2. Those are both positive. So now what is r? So r is root 2 squared is 2. R is 2. Okay. Sine of theta is opposite over hypotenuse, so root 2 over 2. Okay, reciprocal of sine is cosecant. That's 2 over root 2, and if you rationalize this, it should give you root 2. So yeah, cosecant theta is root 2. Okay, cosine theta is adjacent over hypotenuse, so root 2 over 2. And therefore, secant theta is going to be root 2. Tangent theta is opposite over adjacent, which is 1. And so cotangent theta is going to be 1. Suppose that the point xy is in the indicated quadrant. Determine whether the given ratio is positive or negative. So we're given, for each one of these problems, we're given a quadrant and then a ratio. And we want to determine whether this ratio is positive or negative. So, all right, what we know the r is always going to be positive, so it's just a matter of determining, for this problem, is the x positive or negative? Well, okay, quadrant 2, a point in quadrant 2, we're drawing the hypotenuse to like a point like that. Well, the x is negative. Again, the r is always positive, so negative. Okay, quadrant 3, and then the value x over r. Okay, so quadrant 3, just anything out here. And then we create a right triangle going to the horizontal with the perpendicular at the horizontal. Okay, the x is what? The y is negative and the x is negative. We're only looking at the x here. X divided by r is negative. Okay, third quadrant. So anything out here, create the right triangle. So x is negative and y is negative. Now, okay, we're doing y and x. Okay, yeah, so x is negative, y is negative. So that means negative divided by negative is positive, so this is positive. Okay, quadrant 1, anything out here. Let's create the right triangle with the perpendicular along the horizontal axis. Okay, so x and y and r are positive. So no matter what, everything is positive. All trig functions are positive for quadrant 1.